Okay, consider the following problem. We have a rod which is in the position between two walls. There are no frictions here and there, and you let it go, and eventually it will fall. Okay? The problem is to find angle alpha, which will change with time, when this end will separate from the wall. Okay. To make that more clear, let us consider force. Force is acting on that rod. Of course, we will have force of gravity, mg, right? And we will have reaction forces. One is here, we call it N1, and one is there, we call it N2. Since we ignore friction, we say there are no friction, they are all forces acting on this rod. Okay? And the moment when this end of the rod will be separating from the wall can be also described as a moment when reaction N1 will be zero. So, using a coordinate system, x, y, we can write second Newton law for the horizontal direction. So we have m of the rod times acceleration x, right, equal n1. That's it. And the problem is to find this n1 as a function of the angle alpha. So, first of all, this is not a point mass, but a solid, and the motion of the solid can be decomposed as the motion of the center of the mass and rotation around the center of the mass. Okay, let's introduce L will be the length of this rod. Okay? And because rod is symmetric, we will consider center of mass is like on the middle. Okay. Thus, coordinates of the center of the mass can be expressed as center of the mass equal L over 2 times cosine alpha, and y of the center of the mass equal L over 2 sine alpha. All right. From here we will make a very interesting observation. Notice, if we will consider x square center of mass plus y square center of mass, we will end up with a square over 4 times cosine square alpha plus sine square alpha, which is 1 inside the parentheses, equal L squared over 4. What we have? We have a very good observation that center mass is always lies on an arc of the circle, So there is some circle. Let me see. Something. And here, our center of mass always will on this circle. This will make our life easier. So, considering A sub x, what is A sub z? Is a projection of the acceleration onto horizontal direction. What we can say about acceleration? Acceleration of the center mass will consist of two parts, so-called centrifugal acceleration, we call it A sub c, and tangential acceleration, A sub tau. Okay. Some geometry will help us to project. Notice, since this distance is L over 2, right? The square of the distance is L square over 4, so distance is L over 2, and this is distance L over 2, meaning this angle is also alpha. Thus, projection of centrifugal acceleration ACX will be AC times cosine alpha. And projection of the tangential acceleration A tau x will be AC sine alpha, because they are mutually perpendicular. Now, what is A sub c, centrifugal acceleration? And A sub c can be found as omega squared times L over 2, and A sub tau can be written as epsilon, is the angular acceleration times L over 2. Okay. To find this omega and epsilon, we will first use law of conservation of energy. Okay. Let's see. From all forces, the only one who does some work is mg. Right? Because look, n will be, or both ends are perpendicular to the direction of motion of the corresponding ends of the rod. Right? Therefore, they will produce no work. Mg will make work. Where this work will go? And work will make a whole rod rotating, right, about the origin. So, what the law of conservation of energy? I omega squared over 2 equal work of gravity, which is mg, and delta H. Delta H is the same as change in coordinate of center mass, vertical coordinate. If initially we had A sub 0 at time 0, alpha equal A sub 0, therefore delta H can be written as L over 2, parenthesis open, sine of alpha 0 minus sine of alpha. Together, before I say that, let's find I, rotational inertia of the rod. Since from any table the inertia of the rod about this point, center mass, will be m L squared over 12. We need to add mass times square of this distance. So we need to add m L square over 4, which returns m L square over 3 for rotational inertia. Therefore, law of conservation of energy can be rewritten. M L square over 6 times omega square equal m G L over 2 times this difference of sine of alpha sub 0 minus sine alpha. Simplification, little simplification will let us rewrite omega square equal 3g over L times expression inside parentheses. Okay. Therefore, A sub C, or centrifugal acceleration, is just 3/2 G times difference of sine. All right. To find out epsilon, please recall the formula that epsilon equal d omega over time. Okay? So let's differentiate, and we will have 2 omega times epsilon, right? Equal 3g over L times negative cosine alpha times d alpha d. So but d alpha over dt is what we call omega. So we have 2 epsilon equal negative 3g over L times cosine alpha. Epsilon equal negative 3/2 g over L cosine alpha. And A sub tau equal, using that expression for epsilon, negative 3 over 4 g cosine alpha. Okay? So now we need to project them and add together. And then multiply by mass and get our N1. So to project, we will use A sub C times cosine alpha. So we will have three half G times cosine alpha sine alpha 0 minus sine alpha cosine alpha. Okay? And then we will add projection of a tau. A tau we multiply by sine, and we will have minus 3 over 4 g cosine alpha sine alpha. All right. If we multiply this expression by m, we will get n1. But our goal is not just to find n1, but to find angle when n1 is 0. So there are no reason to multiply by m. We just equate a whole expression to 0 and see what's happening. And what will happen, I need just to do algebra. So first, let us make the same denominator, right? 3 over 4 g times 2 cosine alpha sine alpha 0 minus 2 sine alpha cosine alpha, right? Minus 3 over 4 g cosine alpha sine alpha equals 0. Okay, so we can cancel this term by dividing both sides of equation by 3 fourths g, and we will have what? 2 cosine alpha sine alpha 0 equals 3 sine alpha cosine alpha. Okay, cosine alpha can be removed from both sides. Cosine alpha is not 0, because what is cosine alpha 0? Meaning that alpha is 90 degrees, so it's just straight vertical position which we're not considering here. So we just cancel cosine alpha, and then sine of alpha equal 2/3 of sine of alpha sub 0. That's it. For example, if you know alpha sub 0, imagine alpha sub 0 is 30 degrees. Then sine of 30 is 1/2, and then angle when this end will separate from the vertical wall will be such that sine of this angle will be 1/3. So using calculator you can easily find. I guess that will do. Thank you. Bye.